All right. We have about 30 seconds left, but let's at least start with the introduction. So thanks, first of all. I think you are the only ones who braved through the last 3 days. CUC, most of them are gone. We'll not make this very difficult so that you can safely leave home. My name is Manish Mehta. I'm Chief Security Architect at Volterra. We do some cloud computing and distributed cloud edge computing platform stuff.
Okay. I'm Derek Suzuki, the Director of DevOps for the Voleon Group. We're a financial services company up in the Bay Area. My team does pretty much everything DevOps needs to do: CI/CD, testing, container infrastructure, logging and monitoring, and so forth.
So we'll get started. I'm going to kick off, and then Derek will explain whatever we discuss here, how how this kind of design helps him solve the problems that the Voleon group is trying to solve. So very quick introduction, not a sales pitch. So we are a SaaS provider. We aspire to enable customers to build, deploy, secure, and operate distributed applications and data across multiple cloud providers and edge locations. All right, so it could be either or both. All right, so I'm not going to go into a lot of detail here because I think in the past a lot of blogs have been written, a lot of folks have talked about why multi-cluster and stuff. So TLDR is, if you're not running multiple clusters, Kubernetes clusters today, it's just a matter of when, it's not if. You will get there sooner or later. So whatever we're going to talk about today is, although came to light in our design when we were doing the multi-cluster stuff, it doesn't necessarily mean that it's not applicable to single clusters. Most of them are, and once you start right in a single cluster, you can easily expand into multiple clusters. And today we are going to show some challenges that we ran into. Of course, there are many, and we are going to today focus only on isolation when you have multi-tenancy. In our case, tenancy actually is at 2 levels. We have multiple customers, and within every customer, we have multiple tenants. So let's say different BUs or something. So how the isolation works, and more importantly, how the security works, which is kind of some buzzwords you have probably heard over the last 3 days, and we'll go through them as well. So first of, as we stated, the goal was to actually be able to deploy, secure, operate distributed applications. So we didn't necessarily have to use Kubernetes, but we chose Kubernetes because of the following reasons. And it's pretty extensible, and one of the examples that you will see today for identity is due to the fact that it is actually extensible. So motivation, why I actually wanted to have this identity-related talk to begin with, right? So the reason was 2 years back I was on this stage meaning KubeCon in Austin, not here. But I was talking about, at that time I used to work for Netflix, and I started talking about authorization, how we handle authorization. However, what happened between then and now, multiple people started talking about, hey, you're using OPA. I think this was the first presentation OPA had, at least in KubeCon, if I remember correctly, that started using for authorization. The thing was, a lot of people were very interested. It's a great product, but they did not know how to get there. So they started talking about auth-z, which is their goal. However, they didn't have a solution for auth-n first. So I'm like, you need to figure out how your auth-n is going to happen, then you can go to auth-z. Then they say, okay, fine, so auth-n means MTLS, right? I'm like, yes. What does MTLS need? Certificates. Oh, my problem shifted, right? So the problem shifted to identity. So until you solve the problem of identity, it's kind of meaningless to talk about auth-n and auth-z, because it is where everything is rooted. Okay? Now, we'll talk about how different people take different approaches for identity and what our approach is, right? So let's start with first principles. How do you define identity? So if you go to dictionary today, you will see something like this. And today, if you don't take anything home, you take those 2 words home that are underlined, unique and entire. So what we want to make sure is anything that is assigned an identity that identity is a unique set of characteristics, and it's the entire set of characteristics. We are not leaving anything out, because if you leave anything out, it will not, may or may not be unique anymore, right? However, this is dictionary definition. Just like lawyers like to put stuff in their dictionary definitions, don't work in court of law. So this definition won't work in court of crypto geeks. So you have to have a crypto geek definition with all the crypto stuff interlaced into it. What this is trying to say is basically, if your identity is not solid, it is not coming from a channel, from a protocol that is secure enough, and you understand all the way down to where the keys are generated and stuff, the identity itself is weak. If identity itself is weak, your foundation of security is weak. And then there is really no point in talking about auth and MTLS, auth on top of it. All right, so let's start with why do we need cryptographic identity? So most times you will hear MTLS thrown around all the time, secure communication, MTLS. Sure, it's just one reason why you want secure identity. That means you want cryptographic identity that is useful when you do mutual TLS. However, what we forget is we also need mutual identity, especially in cases like ours, because we are providing a platform for our customers, and we don't make any judgment about what kind of workload they will be running on that platform. They may be using their identity to actually attest something, say something about, yes, this is coming from me. So it is not just about communication. There is something about proving eligibility, vindication. It's audit from the verifier's perspective. If something happened, I actually have to keep a record and know precisely exactly which piece of code make that call. And that is not, identity cannot be loose there. Right? And we'll go there into the granularity of it. So what makes a solid identity? So in the course of this, designing our solution, I wanted to basically bubble this up and basically try to categorize them in main categories. So the main categories I came up with, there are three things, which are granularity of the identity, how granular it is, and we'll get into the actual examples of it. That means everybody has heard of least privilege, principle of least privilege. That is the resource side of least privilege. Don't give resources more than what somebody needs. However, nobody talks about the granularity on the identity side. That means give the access only to people who actually need. So there is a difference between that, and we'll get there. Second is how to deliver your identity securely and mint it and deliver it securely. So for example, if I told you, your password was set by administrator and he knows your password, you cannot change it. That's not securely delivering it because somebody knows your password. We'll get into that. And last one is rich and usable identity, which means whatever identity you are getting, as in this particular case, we'll be talking mostly about X509 certificates. What does that X509 certificate contain, and what makes it usable or not usable? Or if, in order to use it, what kind of changes you will have to make? So all those kind of things have to be also considered. All right, so let's start with the granular one. So very first thing first, when we started, at least I started reading about Kubernetes, this is the first thing I went through in the documentation. Pods are the smallest deployable units of compute in Kubernetes. All right, so if they are the smallest deployable unit of compute, why would you not want to know, for forensics purposes, auditing purposes, or whatnot, exactly what pod performed a particular given action? If you see most of the solutions talked about nowadays, their identities are either based on namespace, and we'll get into it, namespace, its service account, its service, but you can imagine all three of them basically can have multiple pods that will satisfy this condition. Multiple pods can be in one namespace, multiple pods can be in one service account, multiple pods can be attached to a service. So the identity is not any of this. Identity is actually pod. So let's start with them. A given pod can have a service account. A given pod can be attached to a service. A given pod can be in a namespace, but those are attributes of that pod. Those are the attributes of the identity of that pod, right? The reason I say this is identity boundary is trust boundary. some years back, some blogs were written, and I think it was said a little bit differently, like identity is the new perimeter. Some of you may have heard that. The point is that whatever your identity boundary is what you trust. That means anything outside of that boundary cannot take your identity and do something without your knowledge, right? So, because once they do, that means you are trusting them to act on behalf of you, which is not the point. So, let's talk about the second one, securely minting and delivering. How about, I gave an example of an administrator giving you a password. He sets the password, he gives you the password and says, keep using this password, you cannot change it. How comfortable would you feel, right? So same thing, if a pod is running, somebody else is minting the private key and handing off to you, not a great solution, right? Or the private key is generated somewhere outside and handed off to you, right? Or is put in a location which is actually accessible by more than that pod. Not ideal, because somebody can actually take your private key. It's called private for a reason, right? So you have to think about all these things. The system that is minting the private key, is it outside, inside of the pod? The system that is minting, if that was compromised, what is the blast radius, right? If the CA is actually sitting right on the cluster, right? There are some solutions where the CA is actually sitting on each cluster. So if I'm running 1,000 clusters today, if one of them compromises, right? That CA can be used to mint certificates for any other clusters. That's not a great design, right? So we have to consider all those things. And then we also have to make sure that the delivery mechanism of your identity is not limiting the use of the identity. When I said I don't want to make any judgment about what kind of workload is being run on that pod, what it means is I cannot necessarily say it's an HTTP server, or even it's a TCP-based server. It could be running something that needs identity for IPsec. So as a platform, at least as a provider of a platform, those kind of assumptions are out of question. So some people actually, I was discussing this, like, does it mean that your thing cannot be used for service mesh? Yes, it can be used. What I'm saying is we are not tying our identity to any particular use. So in this particular case, if your delivery mechanism is tied to some particular way of using, for example, service mesh, what is being talked about, it is tying you to that TCP-based service, HTTP-based service. But guess what? A month from now, you're going to have database or something that doesn't use HTTP protocol, or sometimes doesn't even use TCP protocol. What then, right? Plus, of course, it is service. It may not even be a service. It can be a K8s job, which basically comes up every 24 hours and dies. In 24 hours, it comes up, runs for 10 minutes, makes a bunch of calls. They all have to be authenticated. That means this guy needs identity to talk to someone else. But the guy dies. It's not a service. So that is why your identity is not tied to necessarily the service. It is the pod. Next is rich, usable, and extensible. So as I mentioned, in this case, we will talk about X509 certificate. So what is in the certificates document? What is contained in the certificate is very important. So of course, in regular certificates, you are very used to seeing DNS names, right? In case of Kubernetes, it will be service names somehow translated to DNS names. The question is, what makes a good set of identity attributes that you want to put into the certificate? The answer is anything that you want, because ultimately, if it is your identity certificate, you want to be able to control what goes into it so that you can prove to somebody that I'm a male, I'm X years old, or I have black hair, or whatever. So what attribute I want to prove to somebody else, I get to decide what is contained in my identity document. So we'll get to how you can control those things. And also, I don't want to put it in a way that I have to make everybody else change their libraries so that how to parse my certificate now, right? Because it looks so different from anything that is standard in RFCs. So those are another other set of things you may want to consider. And last thing I would say is if let's say a pod is running in Kubernetes and you have given this identity, can you write something very simple kind of translation service where the identity, although it is coming from within your cluster or multi-cluster environment, and now you want to give this guy IAM credentials from AWS. how easy is it to first take the natural identity and then convert into IAM or Google or Azure, wherever you may be running, right? All right, so this is a busy slide. This is basically what Volterra sort of shows on their glossy. For this presentation's purpose, I'll try to simplify this slide. The point is that there are a lot of Kubernetes clusters running in a lot of different environments. And these are also, of course, online. So if I simplify this design, you can, the diagram, you can imagine there's a big SaaS backend that has all the controls, control panels or control systems from Volterra that are running that are able to control and deploy Kubernetes clusters across different environments. It could be public cloud, any public cloud provider. It could be your own private cloud. It could be data center, edge location, industry, factory floors, whatnot, right? All at once. You run multiple Kubernetes clusters, and SaaS provider basically is able to control, configure all of them individually based on just labels, right? So let's see how this works. And if we take example of one, we will be able to basically just extrapolate and generalize. So what we did here is we'll take example of one, and every customer on Volterra platform gets a completely separate CA, so they are not intermingled. So there will never be a case where one workload from customer one is somehow able to talk to customer two. So here, what we do is, let's say that there is a Kubernetes API server, and we first install something called Voucher, which basically serves two purposes. It's a webhook, which is a mutating webhook hooked into the pod creation process. And then there is something called Watcher. The Watcher is basically watching for some objects on Kubernetes API server. Now, this is the initial setup. This is running in completely different namespace, which is privileged, and it's considered Volterra's platform. So customers don't have any of this access. Let's say customer schedules a pod, and a pod is basically consistent of consists of one application and one sidecar. This pod creation request will be intercepted by the webhook, and it will automatically inject a sidecar called Wingman. And our goal is to basically actually open source Voucher and Wingman as part of this talk. It's got engineering wise, it's got delayed. The point is that Wingman, as you can see, is actually inside the pod. It is not sitting outside the pod. As soon as that happens, Wingman goes to Identity Authority, which is the backend for SaaS, Volterra SaaS, which is nothing but that tenant-specific or customer-specific CA, and gets an identity back from there. Some details are skipped here in interest of time, but if you're interested, you can come back and talk to me. The point is that that pod now got this certificate, and there are two main aspects of this certificate to be remembered. It is global identity. That means this pod certificate now can be used across all clusters. We just tested 3,000 clusters last month. So that can basically have a huge usefulness, because every pod can talk to any other pod in those 3,000 clusters as long as your policy allows. The point is the identity is valid across. And as you can see, what is inside the thing? Inside the certificate you have lots of attributes, and those are all configurable. And this is what I mean by, if it is my identity, I get to choose exactly how the world sees me or how I want to present myself to the world. So these are all configurable items in Volterra's identity. And what happens is, and this is also important, you can have a pod that gets basically attached to another service after the pod was launched. That means the identity also changes. One more attribute to identity got added. So in this case, the Wingman, as soon as it is launched and gets the first set of certificates, immediately starts watching Voucher, which will notify it if anything changed about that pod. And if anything changed, it will go back to Identity Authority, get a fresh certificate. So all the rotation, all those things are already taken care of. The point is, though, the certificate was generated, private key was generated, and never leaves that pod area. Okay, so your trust boundary is still within the pod. If I have that identity once with me, we can now use it for something like secrets management, right? Which can be completely third-party solution. In this case, we have Volterra Secrets Management, which is a slightly different way of thinking about secrets management, because even though we we are able to decrypt the secret for the customers. We never get to see them, and Derek will talk a little bit about that. So if you zoom out a little bit from pod view to the cluster view, you can see that the pods are actually in separate namespaces, but the namespaces themselves are network isolated. What it means, this is actually a unique feature in some ways, is because customer namespaces never get to talk to the Kubernetes API server or any of the Kubernetes internal infrastructure. And it may run some counter to some of your understanding, but if you see trail of bits security assessment, you will see that almost all of the high security problems in K8s actually came from within the cluster. We just locked that down. So if you are running in a namespace, you only get to become or talk within namespace or other namespaces of your own within that customer account, but you never get to talk to the Kubernetes API server or any other infrastructure. So in summary, once you are done with this, you can achieve something like this without doing any security-related stuff. This is all out of the box, right? So the point is that if you have multiple of these clusters, a lot of people are trying to figure out how to make these guys work together. So this is what identity gives you. Derek will now talk about a little bit more about the secrets management part as well. Thanks.
Thanks, Manish. Okay. So a little background. We started our container journey about 4 years ago. We were starting to deploy Apache Mesos as a platform for running distributed job graphs, and we weren't even really thinking about containers back then. But after we had a few apps running on the same infrastructure, it became obvious that containers would be a great way to maintain consistent execution environments and reproducible testing. And so within a few months, we converted all our deployment pipelines, our infrastructure to run these jobs on containers, and that was really successful, and we've been doing that ever since. Then over time, things expanded. We rolled out more clusters. We implemented Mesosphere DCOS, started doing some work with services. So that led us to the Mesos Kubernetes engine, as well as some standalone Kubernetes implementations. And these clusters would be launched in an office, in a data center, in the cloud. But in any case, each one was an island. It was managed separately from the others. There weren't a lot of early use cases where one cluster needed to talk to another, but that is starting to become more of an issue for us and a management problem. But the infrastructure was getting more complex, so was the development organization. And we had a lot more use cases where one development team would not have any reason to access the credentials or data being used by another. So we started really looking to our options for serious secrets management. And getting started, there were some obvious places to look. So standard Kubernetes secrets available out of the box. They have their limitations, but they were easy enough for us to get started with. DCOS Enterprise has its own embedded secrets vault, and we were able to use that to inject secrets into jobs. Maybe a more robust solution, but it has its own limitations. The access rules aren't as flexible as we would like, and it's also limited in scope to a single cluster when we have many clusters at that point. So we started looking into ways to manage secrets globally, and so one thing we started to do was to set up HashiCorp Vault as a way of sort of managing secrets outside of any particular cluster. And we might have a single source of truth for a particular secret because it was pretty common to have, say, a database password that was needed in 3 different clusters. It was pretty annoying to have to keep it updated in 3 different places. We'd probably get it wrong at some point. So how to tie everything together? Our instinct is to just build things ourselves. The products all have pretty robust APIs. It's not hard to spin up a basic rules engine and some connector code. Basically pull secrets out of Vault, stick them into whichever clusters need them, take it from there. One drawback is, of course, that's just another piece of software you have to maintain. But the bigger issue is that once the secret gets into a cluster, then you're still subject to the limitations of whatever that cluster's secrets management allows. And it's also another layer of management you have to go through to get the secret into a particular container or application. And then we tried coming at this from the other direction, which was to try some of these third-party container security platforms like Aqua and Twistlock. And these are fairly comprehensive platforms with a lot of capabilities beyond secrets management, but I had a smaller team at the time, and we didn't have the resources to look into all the other stuff, so we were focused on secrets. And what we found was, they were able to work with something like Vault externally and propagate those secrets into all the different clusters, so that was good. They also had very flexible rules engines to determine which applications would get each secret. And also good is that management of these security policies was decoupled from management of the clusters and the applications. So it was a little easier to figure out how we would separate responsibilities on the technical teams. On the downside, there were pretty new products at the time, and to be fair, this was like over a year ago when we did this. There was just a lot of added complexity involved, and we were already making the environment more complex, and so we decided we probably didn't want to take that on at that time, at least, and it would probably be more worthwhile once we were prepared to evaluate all the other functionality that they had to offer. So we backed off for the time, and we're prepared to revisit them at a later date. So for the moment, we have solutions that are essentially good enough for our current use cases. We can iterate on them and make them incrementally better, but we also wanted to take a step back and think about what is our future architecture going to look like, and what capabilities do we want out of the security tools. And when it comes to security, we kind of want a little of everything. At the 10,000-foot view, we want to have that single pane of glass and enterprise management console that can control this functionality across different clusters, different environments, different implementations. We want to be able to store those configurations in one place. We want to store secrets in one place. But if it's in a vendor's infrastructure or software, we, of course, need it to be encrypted when we hand it over to them. And then zooming way in, we want to have really fine-grained control over which app, which pod or container can access which secrets, and apply these access policies in a very selective fashion. We also want to make sure that when secrets are being transported from the central store into the application containers, that they don't get decrypted until they've entered infrastructure and software that we control. So when I first started talking to Volterra, they were mostly talking about the service mesh functionality at the time, and that was of great interest to us, but it's on a longer time horizon for us. But when they started explaining their plans for global identity, for security policy management and secrets management, that piqued my interest because it seemed like they were really considering the sort of specific concerns and requirements that we'd already raised internally. So their web console is that single control plane to manage their functionality across potentially thousands of clusters. They will store the secrets for us, but they never touch them unencrypted. Their use of identity as a selector for security policy potentially gives us a lot of flexibility over how we want to apply those policies. And then their technique for getting the secrets into the pods also seems to work pretty well from our standpoint as far as limiting exposure. So it's still pretty early days for us with Volterra. We're still discussing a lot of the architecture and our own plans, but I like what I've seen so far, and I look forward to working with them to see how they can fit into our future architecture. Yeah.
So as I mentioned, this was not supposed to be a sales speech, but I would say one of the things I want to stress is the identity piece, because that has nothing to do with even Kubernetes in some ways. This is a philosophy where the smallest piece of code that you run and you want to identify separately is how you are going to put identity together. And then whatever mechanism you end up choosing, it needs to basically go all the way down to that smallest piece level. In case of Kubernetes, it just happens to be a pod, right? So just to recap very quickly, if you want a solid identity, try to think of three main aspects: granularity, how granular your identity is, it's pod level. How it's minted, is somebody else generating private key and just handing off to you? Good enough for you, then that's fine. From cryptography's perspective, really not. Rich, usable, and extensible, very important, because unless your identity document is rich or it's not extensible, you are not going to be able to write very good authorization policies. Authorization policies effectiveness and granularity directly depends on granularity of your identity and resource. So this was the first part. And takeaway is it's a fundamental problem. Identity is a fundamental problem, and then only when you have solved this and completely grokked it, you can move on and talk about MTLS and OTZ and all those things later. Abstract away identity from provisioning from K8s. And when I say K8s, actually it's not just K8s, anything that you run. Your identity, if you keep it one level above your infrastructure that is actually running the code, that will help you go across infrastructures as well. We can do the exact same thing on some platforms which are not even K8s and still be able to make K8s workloads talk to non-K8s workloads under the same global identity. It's just that the abstraction layer is one level above. We'll just figure out how to do that in the other way of doing it. Multi-cluster deployments turned cumbersome into unmanageable. I mean, I'm pretty sure that if you are administrator of Kubernetes today, you have been tired of writing service accounts and cluster role binding and trying to make sure that this secret injected into this namespace is not available to other people in the namespace. And for that, you have to basically be very diligent about loading launching every application in a separate service account and manage those things. Fine, maybe you can do that in one cluster, 2 clusters, 5 clusters. Once you start talking about tens and plus, it's unmanageable. So if you have this engineering right, then it doesn't matter how many clusters you add. There's no federation, nothing required, because you're basically just adding to your infrastructure without actually changing any of the underlying mechanisms, how you get the global identity. And the last things I would say is secrets are called secrets for a reason. So I'm just tying this into identity because they are the very next thing people talk about after identity is solidified, although it applies to any OTZ. But secrets, for the reason they are very sensitive, please make sure that when you use your secrets, you are using the most granular identity to identify how you're going to limit the access to those secrets. Because most lateral movements, I don't know how many of you were there here in the previous talk, but most lateral movements will happen that way, where people pop something, and then immediate thing they will try to do is try to read what this guy can actually go grab more things. So if your secrets were sitting in your K8s secret in some namespace and it was popped, it will basically go read all of them and then laterally move somewhere else, start attacking other pieces of infrastructure. So we are here for maybe couple of more minutes for questions, and then we may have to take them questions outside. But yeah, thank you for your attention.
Track host.
Oh.
Yeah.
There's a mic in the, the aisle. Any questions?
How do you convert that identity? This is mostly for the recording.
How do you convert that identity to something that's outside of Kubernetes? Like, for example, if I want to use that pod and use this identity mapped to like an IAM so that I can call like an S3 get or something?
Very good question. So the question was, if I have an identity in the pod, and now I want to map it to some identity which is, say, underneath it's running on AWS. And now I want to give a very specific role to this pod, and so that it can go off and maybe download something from S3. The thing is, the person who's in charge of the cluster can always define that this pod will have a label of AWS IAM role, right? And then as soon as that pod's identity contains that label, it can go off and have another agent, just like we have voucher. You can basically launch something that is allowed to go to STS service in case of AWS and exchange it and give it a particular role. Right? It's the enabler. It doesn't come for free, but it's the enabler. If you do the exact same example in case of if your certificate only had, let's say, a service account. If it was only service account, if you were not doing this diligently where every application was put in its own service account, You will not be able to do that because other people will have the exact same service account to go exchange it. Sorry, there's one more part. Yeah.
Thanks. So quick question on the Wingman protocol, like how you use Wingman and deployed it. How does that differ with Spiffy protocol, where each like Spiffy assigns like identity for workloads and nodes as well?
So Spiffy works slightly differently. Spiffy technically does not dictate that you need to have a sidecar like Wingman. That's number one. Number two, Spiffy says, actually I shouldn't say Spiffy, it's more like Spire, because Spiffy is just how you name your thing. And I mean, nothing precludes us from using Spiffy way of naming something here, right? Spire is more sort of appropriate. So the way Spire works is it basically allows you to go to something called workload API and pull out your sort of private, your credentials. The point I was mentioning here is that piece Spire sits outside of your pod. It generates private key for you, right? It's different way of thinking about it. And there are other basically, aspects of security you may want to consider when you consider the platform as a whole. Because in our case, as I mentioned, we are in edge computing business. Some of the edge boxes will be sitting on some unmanned area where it is quite possible that somebody will compromise one of them. We just want to make sure that when one of them is compromised, the damage is limited to that box. Right? So it's a different approach, but the risks are also different. So you may want to consider it. Yeah.
Any other questions? Okay. Thank you guys for coming.
All right. Thanks again.